Good morning, everyone. Today I'm going to go over a few examples of how to find the volume of a pyramid and a cone. I literally took the examples that I would do in class for you and put them on this notebook, and we're just going to go through them together. So, first example, this is a pyramid. I know this is a pyramid. Most of us know what a pyramid looks like at this point, but we have a square-based pyramid here. So we have the square down here. And then we can see how, this is our square, and then we can see with the height of it, this is where the pyramid comes to a point. So what we're going to do is find, using this formula, we have 1/3. And the reason why this 1/3 happens is because this actually, a pyramid comes from a cube. A square-based pyramid comes from a cube. So it's as if we just took a slice out of the cube. So we only need 1/3 of that volume. So if you remember in the previous video about finding the volume of a prism, this looks the same. The area of the base times the height. The only thing that's different is that we're multiplying it by 1/3 because it comes to a point up here. So we got to account for the fact that we only want 1/3 of that volume. So what I really want you guys to focus on is that we're not really doing anything different. We're just taking a chunk out of a prism that we already know how to find the volume of. So we already know how to find the area of a square, which is going to be length times width. So I'm going to go ahead and just rewrite our formula for this case. So we have length times width times the height. So the volume is going to equal 1/3 times 5 times 5 times the height, which is 10. And again, I'm just going to put this in my calculator. If you do not have a way of putting in fractions, you can just do 0.33, and that would be close enough. So we have 1/3 times 5 times 5 times 10, and that's going to give us 83.33. And we don't have a given unit for this problem, so I'm just going to put U cubed. So whatever the units are, we know that they're cubed because it is a volume problem. So just like yesterday, we had to find the area of that base and multiply it by the height. But then we had to account for the 1/3 because we don't have the full prism here. We have a pyramid which is being taken out of the prism. This next example is also a pyramid, except for this base is now a triangle. Now, I don't want us to get too lost in this problem and all the formulas that come with it because of the multiple fractions that we're going to have to look at. I really want you guys to just break this down like we did yesterday, where we're going to find the area of this triangle right here, because that's the base of my pyramid. Then what we're going to do is multiply it by the height, and then we have to multiply it by 1/3 because we don't have the full triangular prism. We have a pyramid. So let's go ahead and rewrite this formula, and it is going to look a little scary, but please rest assured that all we're doing is finding the area of the base, which here is going to be 1/2 times the base times the height, and then we have to multiply it by the height for this 7 right here, the whole height of the pyramid. So please, 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 just relax a little bit, because I know that it is a little scary to see all these fractions together. The base of this triangle here is going to be 6. The 10 is the hypotenuse. That is not going to be the height. It is the hypotenuse of this triangle. And so we cannot use this. Remember how we were drawing the arrows to find our hypotenuse? We cannot use 10 to find the area of this triangle. We have to do 6 as the base, and 8 is the height for the area. So we're going to multiply this by 6 times 8, and then we got to multiply it by 7 because that's how tall it is. So, again, in your calculators, if you cannot use the fraction button, you can do 0.33 and 0.5. So I'm going to multiply this out. And we end up with 56. And here we do have our units given to us as centimeters. So I can put centimeters cubed. Okay, again, we cannot use 10 as the height of this triangle. We have to be able to identify the base, find the area of whatever that base is, and then multiply it by how tall something is. I put another example of a triangular prism Sometimes those are a little bit more difficult to see. So let's highlight the base again. So here we have another right triangle that is our base. That's the shape of our base. So I know that to find the area of the triangle, I'm going to have to multiply it by 1/2 times 3 times 4, because that's the base and that's the height. And then we're going to multiply the whole thing by 5, because that's how tall it is. But again, we're taking a chunk out of the triangular prism, so we have to multiply it by 1/3 as well. So let's go ahead and rewrite this formula. Okay. And we know that we have the base is going to be 3. And the height of the triangle base is 4. And then the whole thing is 5 centimeters tall. So again, we're just going to put all of that in our calculators. And we end up with 10. And again, for this problem, our unit is centimeters, and we have to use cubed because we are finding the volume. So I know that this seems like it's a little confusing because we have those double fractions there, but what I want you to see is that this piece right here is just us finding the area of the base, that big B, right there. That's all we're doing. So it doesn't matter what the base is, we just have to find the area of it. So the reason why we have that 1/2 right here is because the base is a triangle. Let's go ahead and move to example 4. Example 4 is a cone. We know it's a cone because the base of this shape, or this solid rather, is a circle. And so, and cones come out of cylinders. So we are going to basically find the volume of the cylinder and then multiply it by 1/3 because that's the only piece that we want. So the two pieces of information that I need for that are the radius and the height. So looking here, I have my radius and I have my height. And those are the only two things that I need for this problem. So let's go ahead and type that in. And volume is equal to, again, I'm using 3.14 because this program I could not find the pi button. You can use what is most convenient for you. The radius here is 2. And then we have the height, which is 5. This problem always bothers me because I do not know of a single cone we would need to measure in miles, and I don't understand why the people who made these examples use that. That would be a really big cone. It always stresses me out every time I do this problem. Alright, so I'm just going to type this in my calculator, and we have 20.93 miles cubed, which is huge, really big. All right, so, but that's how you find the volume of the cone. This is pretty straightforward. These next couple of examples, I really would make sure you understand how to use them or how to solve these, because these are typical test questions. So example 5 and 6 are really important for you to really understand how to do. So for example 5, we have a cylinder. But what I want you to see is that you do not have the height of this cylinder. It would be very easy for you to look at that, but what you have here is what's called the slant height. And so we can use that to find the height of this triangle because, or height of this cone, because we have a right triangle hanging out right there. And we know that when we have two sides of a right triangle, we can use the Pythagorean theorem to find that. So, the Pythagorean theorem we know is A squared plus B squared, and that is equal to C squared. Alright, and then so what we're going to do is we're just going to plug this in. 15 is my C, because that's my hypotenuse. So I have 9 squared plus B squared and that's equal to, sorry y'all, this is a program I have not used like this before. Okay, so when we work this out, we can see that we have 81 plus b squared is equal to 225. And then 225 minus 81 is going to give us 144. So we have b squared is equal to 144. And then we have to take the square root of that. So b is just going to equal to 12. So that right here is what's going to be my height. Okay, that's what we solved for the length of that pink line. Okay, now what we're going to do is plug that in. So we know that the height is now 12. So we have volume is equal to 1/3 times 3.14 times 9 squared, which we found was 81, times the height, which is 12. When we plug all of that in the calculator, we end up with 1,017.36 centimeters cubed. Okay, now the only difference between this problem and the previous problems have been just having to do the Pythagorean theorem to find the height. You'll not have to do that all the time, just when you have the slant height. I do have another example on here for that, just because I really want to make sure that we understand how we do this. Okay, so again, let me just copy and paste this. Okay, so we're going to use the Pythagorean theorem again because we have the slant height. Now here we have the diameter, so that means that we have to find the radius, which means we only want this piece right here. The radius is half the diameter, so our radius is going to be 10. Okay, we want to find the height, so we are going to just plug this in. So we have 10 squared, it's not going to let me do the keyboard shortcut. Okay, 10 squared plus b squared is equal to, and here we have 26 squared. Okay, now we know that this is 100. 100 plus b squared is equal to 676. So we have b squared is equal to 576, because 676 minus 100 is 576. Well, this keyboard is making it hard. And then therefore b is equal to 24. Then what you're going to do is just plug this into the formula where you have volume is equal to 1/3 times 3.14 times 100, because 10 squared is 100, times 24. Okay? Alright, well, I hope that that video helps you with whatever examples. Please feel free to move to the examples that are most helpful for you for the practice.